yesterday we left off about here in the slideshow, I believe. So we finished talking about reference angles. Well, I guess it was more coterminal angles where we said, if we were given some huge measurement of an angle, like one of the examples was sine of 2,500 degrees, we would just keep subtracting 360 until we got to an angle that was between 0 and 360 that we could evaluate. Well, today we're going to start talking about the sines of the trig function. Okay? So what this is saying is if we have some angle in the first quadrant, and if my angle is just right here, all of the trig functions are positive in the first quadrant. And sine, cosine, tangent, secant, cosecant, and cotangent are all positive in the first quadrant. Because, as we talked about yesterday, the sine of an angle is equal to the y-coordinate over r. Right? We said r was just basically the hypotenuse of a right triangle, so we're saying that r value is always positive. Cosine was the x value over r. Tangent was the y value over the x value, and then cosecant, secant, and tangent were just the reciprocals of those. So, since the x value and the y value are both positive in the first quadrant, all of these trig functions will be positive. Okay, so if we then move over into the second quadrant, sine is the y value. Right? Sine is the y value, so if we're in the second quadrant, the y value is still positive. The x value is now negative. So, I like to just think in terms of the first three trig functions, right? Because we know that sine and cosecant are very closely related, so if sine is negative, cosecant's negative. If cosine is negative, secant's negative. So in the second quadrant, sine is positive, but cosine will be negative because it's the x value. Now that would also make tangent negative, because if we're saying the y value over here is positive, the x value is negative. Positive divided by a negative would be a negative. If we're in the third quadrant then, the x value and the y value are both negative, which means both sine and cosine will be negative if we're in the third quadrant. But if we're talking about tangent then, we have a negative divided by a negative, that means tangent will have a positive value. And then finally in the fourth quadrant, the x value is positive here, but the y value is negative. So that means cosine will be positive here, and sine will be negative. So then that makes tangent negative. If we're just thinking in terms of the first three, sine, cosine, and tangent, to remember that, okay, there's all of them are positive here, sine is positive here, tangent is positive here, cosine is positive here. The common trick to remember that is all students take calculus. Okay. Sure, if you took pre-calc last year, Mr. Miller used that one. Right, so all students what? Alright, if you have another one to remember it by, that's perfectly fine, but all of the three trig functions are positive in the first quadrant, just sine is positive in the second quadrant, tangent in the third quadrant, and cosine in the fourth quadrant. Okay? We should move towards just being able to look at the graph, though, and recognize, well, cosine is the x value. So cosine is going to be positive in these two quadrants, because that's where the x value is positive. Sine is the y value, so sine is going to be positive in these two quadrants, because that's where y is positive. And then tangent is the quotient of those two. So tangent will be positive positive when they're both positive, and it'll also be positive when they're both negative. Okay. Questions on that idea? So let's use that idea. Okay, so if we're told that tangent is positive and cosine is negative, where's the angle? Quadrant 1, 2, 3, or 4? So right off the bat, if tangent is positive, we know that it's in quadrant 1 or 3. Okay? Then, if cosine is negative, that means we're below the x-axis. That tells me that we're going to be in quadrant 3. Right? So it doesn't matter which one you start with. You can start with cosine and say, well, if cosine's negative, I know I'm going to be over here, because that's where the negative x values are. And then if tangent is positive, that means we're going to be in quadrant 3. Right? What if we're told that sine is positive and cosine is negative? Where are we then? If sine is positive, sine is the y value. So that tells me I'm above the x-axis. So I'm either in quadrant 1 or 2. But then if cosine is negative, that means I'm to the left of the y-axis where the x values are negative. So that would be here, quadrant 2. Okay. Sine's positive, so the y value is positive. Cosine is negative, so the x value is negative. Okay with something like that? So then we can go one step further, okay, and find exact values of a given angle using different pieces here. So in this example, we're given that tangent is equal to 3/2 and cosine is negative. So from that information, first, we want to figure out where we are, which quadrant. Okay, so we know that tangent is positive. We're given a positive value for tangent. Cosine's negative. So if tangent's positive, cosine's negative, what quadrants are we in? 3. Right? So let's sketch out this situation. We're going to create a right triangle using this information. So tangent tells me opposite over adjacent. So we determined we were in quadrant 3. So let's draw a right triangle here in quadrant 3 that has that information. So opposite from my angle is 3, adjacent is 2. Now, since I'm in quadrant 3, these values are negative, right? Negative x value, negative y value. Now, what's up? You don't like my triangle? No. Is that better? So now, if I want to find other trig values, I'm going to need to find the hypotenuse of this right triangle. That, we're just going to use the Pythagorean theorem. So I'll have -2 squared plus -3 squared equals, we're calling it R, right? But you can call it C. You're using the Pythagorean theorem. And so 4 plus 9 equals R squared. So we end up with R is the square root of 13. Hypotenuse of this right triangle would be the square root of 13. So now, once I've found that extra piece of information, I give the exact values of sine and secant. So with respect to this angle, okay, we know that sine is opposite over hypotenuse. So opposite over hypotenuse is going to be negative 3 over the square root of 13. Again, we want to rationalize. So multiply top and bottom by the square root of 13. Get negative 3 times the square root of 13 over 13. Secant, then, we know, is the reciprocal of cosine. Okay, it's just r over x. So secant would be the square root of 13 over negative 2. So we can just put that negative sign out front. So when we're given a problem like this, okay, we want to sketch it out and draw a right triangle. Questions on something like that? Let's try another one of those then. Let's say how about we're given that cosine of theta is negative 5 over 13, and we know that sine is positive. So first, we need to figure out what quadrant we will be in, given that information. Then sketch out our right triangle, solve for the missing side, and then let's say we want to find the other 4 trig functions, or I guess other 5 trig functions. So here we'll go ahead and do all of the other ones. Did we get these trig values here? Okay, so it's important to first recognize what quadrant we're in so that we can get our signs straight. Okay? Since cosine is negative, that means the x value is negative, but sine is positive. That means I'm going to be in the second quadrant. So when I'm drawing my triangle, I would draw this side as having a length of -5, but the y value, right, this other leg of my right triangle will have a positive value because y is positive in the second quadrant. So then that allows us to see that sine and cosecant are positive, but then my other 4 trig functions end up being negative. Okay, so that's a big part of a problem like this is keeping the signs straight. Okay. Questions? Do we want to do another one like this, or are we good on these? All right.